At the end of this video, you should be able to describe one way astronomers measure the distances to stars and explain the difference between absolute magnitude and apparent magnitude. Chapter 30, Section 1, Distances to Stars. Because space is so vast, distances between the stars and Earth are measured in light years. A light year is the distance that light travels in 1 year. Because the speed of light is 300,000 kilometers per second, light travels about 9.46 trillion kilometers in 1 year. The light that you see when you look at a star left that star sometime in the past. Light from the sun, for example, takes about 8 minutes to reach Earth. The sun is therefore 8 light minutes from Earth. When we witness an event on the sun, such as a solar flare, the event actually took place about 8 minutes before we saw it. Apart from the sun, the star nearest Earth is Proxima Centauri. This star is 4.2 light years from Earth, nearly 300,000 times the distance from Earth to the sun. Polaris is about 430 light years from Earth. When you look at Polaris, you see the star the way it was 430 years ago. For relatively close stars, scientists can determine a star's distance by measuring parallax, the apparent shift in a star's position when viewed from different locations. As Earth orbits the sun, observers can study the stars from different perspectives, as is shown in Figure 5 on the screen here. As Earth moves halfway around its orbit, a nearby star will appear to shift slightly relative to stars that are farther from Earth. The closer the star is to Earth, the larger the shift will be. Using this method, astronomers can calculate the distance to any star within 1,000 light-years of Earth.
Proxima Centauri is the nearest star to Earth other than our Sun. It is about 40 trillion kilometers away. Writing out such a large number can be inconvenient and confusing. We can express the same distance as 4.2 light years. A light year is the distance light travels through space in 1 year. Light travels at about 300,000 kilometers per second, so in a year it can travel about 9.5 trillion kilometers. If it could make the journey, the space shuttle would take over 37,000 years to travel 1 light year. The distance across our galaxy in kilometers is written with a 1 followed by 18 zeros. This enormous distance is much easier to express as 100,000 light years.
Stellar brightness. More than 3 billion stars can be seen through telescopes on Earth. Of these, only about 6,000 are visible without a telescope. Billions more stars can be observed from Earth-orbiting telescopes, such as the Hubble Space Telescope. The visibility of a star depends on its brightness and its distance from Earth. Astronomers use 2 scales to describe the brightness of a star. The brightness of a star, as it appears to us on Earth, is called the star's apparent magnitude. The apparent magnitude of a star depends on both how much light the star emits and how far the star is from Earth. The lower the number of the star on the scale shown in Figure 6 on the screen here, the brighter the star appears to the observers on Earth. The true brightness, or absolute magnitude, of a star is how bright the star would appear if all stars were at a standard, uniform distance from Earth. The brighter a star actually is, the lower the number of its absolute magnitude.
Ancient astronomers developed a system to classify stars based on their brightness. They called the brightest stars in the sky first magnitude stars, while the faintest stars they could see were called sixth magnitude. Using telescopes, astronomers today are able to see stars much too faint to be seen with the unaided eye. To include these stars in the system, astronomers extended the magnitude scale in both directions, with larger positive numbers for dimmer stars and negative numbers for brighter stars. How bright a star looks from our location on Earth is called its apparent magnitude, and it depends on a star's distance. For example, these street lamps are all lit by the same size bulb, but the lamps further away seem dimmer. Their apparent magnitude is less. If you remove the effective distance, you would be able to see the light's actual brightness or absolute magnitude. In this case, these lamps have the same absolute magnitude. To our eyes, the Sun has the greatest apparent magnitude of all stars because it is the star closest to Earth. The Sun has an apparent magnitude of negative 26.8. In comparison, Rigel, a star about 1,400 light-years away, has an apparent magnitude of 0.12. If our Sun and Rigel were placed side by side, the effective distance would be removed. The absolute magnitude of the Sun is 4.8, fairly average for a star. Rigel has an absolute magnitude of negative 8.1, making it one of the brightest stars in the sky.
At this point, you should be able to describe one way astronomers measure the distances to stars, and explain the difference between absolute magnitude and apparent magnitude.